Episode 1, Microscopy and Forensic Science. Have you ever thought about how something as small as a single fiber, or a grain of sand, or even a microscopic particle of gunshot residue can help solve a crime? In forensic science, some of the most important pieces of evidence are so small that investigators never notice them without using special tools. Yet, despite their size, these tiny details can completely change the direction of an investigation. This is where microscopes become essential. Microscopy is the use of microscopes to examine evidence that is so small that it can't even be seen with the naked eye. In forensic science, it allows investigators to reveal hidden details, compare material, and make connections between suspect, victims, and crime scenes. In this episode, I'm going to break down how forensic microscopes works, explaining the major types used in crime laboratories, and how microscopy helps investigators transform tiny, overlooked evidence into meaningful forensics conclusion. Parts and functions. Although there are many different microscopes used in forensic science, most of them share the same core parts and functions. Understanding these parts help explain how forensic scientists are able to analyze evidence accurately and reliably. The eyepiece is also called the ocular lens, is where the examiner looks through. It magnifies the image so fine in detail that it can be observed clearly. Most forensic microscopes have an eyepiece magnification of about 10 times. This can vary depending on the microscope. An objective lens are located closest to the evidence and provide the primary level of magnification. Forensic microscopes usually have multiple objective lenses that can be rotated into place, allowing examiners to switch between low, medium, high magnification. It is important because scientists often start with lower magnification to get an overall view before zooming in and seeing the finer details. The stage is a flat platform where evidence is placed. In forensic work, the stage must hold samples steady to prevent movement, since there is a slight shift can distort observation. Some microscopes include magnetical stage to allow evidence to be moved precisely without touching it directly. A light source is another essential component. Proper lighting, it makes detail visible and enhances contrast in forensic examination. Lighting can be adjusted to highlight texture, edges, or surface patterns. This is especially important when examining fibers, hair, and tool marks. Finally, microscopes use coarse and fine focus knobs. A coarse focus brings the image into general clarity, while the fine focus allows precise adjustments. In forensic science, clarity is critical. A poor focused image could lead to a misinterpretation or a missed evidence. All these parts work together to produce a clear, reliable image that investigators can analyze with confidence. There's different types of microscopes. Forensic scientists rely on different microscopes depending on the different types of evidence they're examining. No single microscope can handle every forensic task, so crime laboratories are equipped with a variety of specialized instruments. One of the most common used microscopes is the compound microscope. This microscope is typically used to examine biological evidence such as blood cells, pollen fibers, and plant material. Compound microscopes provide a high magnifications but produce a flat two-dimensional image. While this limits depth perception, it is extremely effective for analyzing cellular structures and small particles. Another important microscope is a stereo microscope, also known as a dissecting microscope. Unlike the compound microscope, it produces a three-dimensional image. This allows forensic scientists to see texture, depth, and small details. Stereo microscopes are especially useful for examining hair fibers, paint chips, soil, and small tools. One of the most iconic tools in forensic science is comparison microscopes. This microscope connects two microscopes with a split view, allowing examiners to look at two samples side by side simultaneously. It is most famously used in firearms and tool mark analysis. By comparing striations on bullets or cartridges casing, forensic scientists can determine whether two items share a common source. More advanced laboratories also use scanning electron microscopes. Instead of light, they use electrons to produce extremely detailed images at a very high magnification. These microscopes are particularly useful for analyzing gunshot residue, explosive material, and extremely small traces of evidence. They can even provide information about the chemical components of a sample, adding additional layer to forensic value. In addition to magnification, microscopes allow scientists to make a precise measurement. Using calibrated scales, investigators can measure the width of fibers, the diameter of a particle, or the space in between striation marks. These measurements can help determine whether two samples are consistent with one another. For example, in fiber analysis, the thickness and shape of a fiber can identify its source. In firearm analysis, microscopes measure tools, marks, help examiners determine whether bullets were fired from the same weapon. Accurate measurements strengthen forensic conclusion and supports expert testimony in court. Microscopes play a role in many real scientific investigations. For example, if a single hair is found at a crime scene, forensic scientists can examine its color structure, measure a pattern under a microscope. While hair analysis alone cannot positively identify a person, it can help narrow down suspects or exclude individuals. In firearm investigations, comparison microscopes allow examiners to match bullets to specific guns by analyzing microscopic markings. These markings are unique to each firearm and act like a mechanical fingerprint. Microscopes also used to analyze like glass fragments, soil samples, paint chips, and even trace evidence from explosives. These microscope clues can link suspects to location and reconstruct how a crime is occurred. Microscopes transform evidence that is invisible into evidence that can speak volumes, allowing forensic scientists to uncover details that otherwise would remain hidden and turn tiny fragments into powerful investigative tools. Without microscopes, much of modern forensic science simply wouldn't exist. From trace evidence to firearm analysis, microscopes remain one of the most essential techniques investigators use in their search for justice and truth.